afternoon, everyone. Let's talk a little bit about some word problems and how we can use systems of equations to solve them. All right, the first problem deals with money, and it deals with interest. Okay, it says Morgan invests $4,000 into two different accounts, into two different savings accounts. One pays 3% per year, and the other pays 4% per year. How much did she invest in each account if she earned a total of $152? Oh man, I got hay fever. That's hay fever. All right, ladies and gentlemen. The main idea here is what algebra ideas can we use to solve this? Well, the first algebra idea is let's break this down into what we know and what we don't know. Well, the question, how much did she invest in each account? Well, that's what I don't know, and so that's where my variables are going to be created. Now, because I have two different accounts, I have to have two different variables, right? So the first thing I need to do is say, all right, let's let our first variable, shall we say x, represent the amount of money that she invested in the, say, 3% account. And let's let y equal the amount of money she invested in the 4% account. Okay? Now, so those are my variables. Now I have to relate these two variables in equations. Well, guys, there are two types of equations in algebra that we need to focus on. One I call a totals equation. One of them I call a comparative equation. A totals equation just says if I have one amount plus another amount, I get a total amount, right? Now, to write a totals equation, I can only add like amounts. Pounds plus pounds equals total pounds. Dollars plus dollars equals total dollars. Interest plus interest equals total interest, all right? So, in this problem, here's what's going on. Let's see here. I know that Morgan started with $4,000 and she split it up into two different accounts. The first account, call it X. She put, the first account, the 3% account, she put X dollars in. In the second account, call it 4% account, she put Y dollars. Well, does it make sense that how much she invested in the first account plus how much she invested in the second account, shouldn't that equal the total amount of money she invested, which is $4,000? Well, guys, that's one equation with my two variables. But of course, we know the golden rule of algebra, the number of variables has to match the number of equations if I want to solve. So now I've written an equation about how much money I invested. Now I can write an equation about the interest that each one yields. Well, to create interest, folks, you take the percent interest that you get from each account and you multiply it by how much money you have. Like throwing it out there just on the side, if you have a 3% account, suppose you put in $50. Well, to figure out your interest, you just multiply 50 times 0.03 and you get 150 with two dollars. You make $1.50, right? So in general, you multiply the amount you put in times the percent, and that tells you how much interest you made. Well, if I'm putting X dollars into an account at 3%, shouldn't my total interest from that account be 0.03x? Similarly, the interest that I make off the 4% account would be 0.04 times y. Well, if I add the interest from the 3% account plus the interest amount from the 4% account, shouldn't I get my total interest of, well, how much did I make totally? Or no, Morgan made a total of $152. Shouldn't interest plus interest equal total interest of 152? Did that make sense? I hope so. So now, wait a minute. Golly, I've got two equations with two variables I can solve. Since both equations are in standard form, I'm going to use the elimination method. But I know what most people, like this young lady here, why is this equation not in standard form?
Because it's a decimal.
Yeah, remember, we don't have standard form with decimals, right? So to get rid of the decimal, couldn't I just multiply this equation by 100, right? If I did, I get 3x plus 4y equals 15,200. Now, I'm going to get rid of the x's by multiplying this top equation by negative 3. If I multiply this top equation by negative 3, I get negative 3x minus 3y equals negative 12,000. Now, I can eliminate the x's by adding two equations together. I get y equals, well, 15,200 minus 12,000 is $3,200. So she must have put $3,200 into this account, which is the 4% account. Okay? Well, to figure out how much you put for the x, well, again, I can plug that number back into either equation. That very first equation seems like the easiest. Shouldn't x plus 3,200 equal 4,000? So subtracting in 3,200, I get x equals $800. So she must put $800 in the 3% account. And I've just figured out how much you put in each account. But again, going through this in slow motion, the first thing it is, you read the word problem in total. Then, you ask what the question's asking you to find. Therein lies your variables. Then you define your variables representing what they equal. Then you have to come up with two equations with things that are countable, like how much you put in each. Dios mío! Okay, let's look at another example. This one's a tougher one. It's a chemistry problem. It says a chemist has two solutions. One is 20% hydrochloric acid, and the other has a concentration of 70% hydrochloric acid. Well, if he has a weak acid and a strong acid, how can he mix these two together to get a medium concentrate acid, a 40% hydrochloric mixture? And she needs 100 milliliters, right? So that's what's going on, right? So she's taking a weak acid, adding it with a strong acid to get 100 milliliters of a in-between acid. So I've got a little diagram here. Let's take a look at this. So suppose I have this picture going on, right? Okay? I've got three little beakers here, right? I think Erlenmeyer flasks is a good name for them, right? So I've got a weak acid here, right? This is the 20% acid, okay? Now again, what that means is there could be a whole bunch of, there could be a whole bunch, but only 20% of this acid, of this fluid, is actually hydrochloric acid. The rest is some other substance like Kool-Aid or Pepsi Cola, okay? Well, now, she takes that and she mixes it with the 70%, right? This is the stronger one. I used a darker color to represent the stronger acid, right? So that's 70%, right? 70% of that is hydrochloric acid, right? So here's what happens. She takes the weaker acid and she pours it into this beaker, okay? She then takes the stronger acid and she pours it in, okay? And what she gets is a mixture that's somewhere in between those two. Notice how this one, how what I've got here, this new mixture, it takes the weak acid, it takes the dark acid, and it makes an in-between colored acid, right? I know that this will be a 40% container, a solution that's 40% hydrochloric acid, and I also know that in total there will be 100 milliliters of solution, not acid, but of solution, okay? Well, let's take a look at what the question's asking me to do here. Well, it says how many milliliters of each must she mix? So my question, how many milliliters of each solution? Well, I've got two different solutions. I've got a weak solution and I've got a strong solution, right? So I'm going to let W equal the weak, or the 20% solution, okay? And I want to let S equal my 70% strong solution, right? Okay. Well, again, the first thing is, I know that the amount of weak solution I have in total plus the amount of strong solution I have has to equal the total solution of 100 milliliters. Doesn't that make sense? Well, again, just like before, if I have 20% HCl, if I multiply this total solution, W, by its concentration, 20%, that should tell me how much HCl I have. plus 70% times the amount of solution I have for the stronger solution. Well, that should equal my total solution, concentration of my total solution. Well, again, I want a 40% solution of 100 milliliters. Does that make sense? I hope. Well, moving forward, again, I would get 0.20W plus 0.70S equals, when you multiply that, what is that, 40? Is that right? Yeah? Again, to get rid of the decimals, I'm just going to multiply everybody by 100, so I'm going to get 20W plus 70S equals, say, 4,000. Now, taking a look at this equation right here, if I want to get rid of, say, the W's, couldn't I multiply him by negative 20 to get the same coefficient here and here? So I get negative 20W minus 20S equals negative 2,000. All right? Well, adding the two equations together, the W's cancel. I get 50S equals 2,000. So S divided by 50 would equal 40. So I must be adding 40 milliliters of the strong solution, the 70% solution. And I must be adding, well, again, if it's 100 milliliters in total, I must be adding 60 milliliters of the weak solution.
Mr. Khan, have you seen the infamous Melendez